Hello everyone, I'm Shruti Kesri. I'm working as assistant professor in Department of Computer Science in ABES Engineering College, Ghaziabad. Today I'm going to discuss counting sort algorithm. Counting sort is basically defined in terms of linear sorting algorithm. Here we will discuss 4 points mainly. First is your linear sorting algorithm. Second is what is the prerequisite of counting sort and how to work the counting sort algorithms to sort a particular element, and what is the complexity analysis, and that is your time complexity and space complexity of this counting sort. When we are talking about the sorting algorithm, we can define that there are two types of sorting algorithm. First, we can categorize sorting algorithm in comparison based sorting, and second is your non-comparison based sorting algorithm. When you are talking about the comparison based sorting algorithms, we have quick sort, merge sort, and heap sort. We are just taking these three algorithms because these three have the minimum time complexity, that is O of n log n. Even though we are using the selection sort, insertion sort, and bubble sort, these all are the comparison based sorting because we perform the sorting based on the comparison. First, we compare the algorithm. It may be adjacent values, it may be a different values, but you need to compare that value so that you can perform the swapping, or you can swap, you can sort the element. So these sorting algorithms have the complexity minimum, that is n log n. When you want to make sorting algorithms a bit faster, then we are using this linear sorting algorithm, that is also a non-comparison based sorting algorithm. But in this type of algorithm, we make some assumption about the input, and by considering that assumption, by considering that constraint, you can say that these algorithms have the complexity of O of n, that is your linear time complexity. These are some prerequisites of counting sort. Yes, to improve the complexity of the algorithm, we make some assumption about the input and perform sorting. First assumption which we are making in counting sort, that it can only be performed when the input type is integer, and obviously that integer should be in a small range. It means you can say that counting sort gets failed when you are having a different range, or you can say large range of integer number to perform the sorting. And in this, we need to check that number should be integer, that element should be integer. This is not applicable in case of float number. This is not applicable in terms of negative number. Even for alphabet, you cannot perform the counting sort. The basic concept of counting sort is that this algorithm sort according to the key value and count the element have distinct key values. To discuss the working of this one, this is first algorithm of your counting sort. Here you can see that you are passing three values, that is first A is the array of which you want to sort, B is this a temporary array which will useful for storing the sorted element, and K is the maximum element of your given array. Means K is the defining how much large element you have taken. You can see the maximum element of the given array. Here you need to arrange a new array that is called as a count array. Here you are defining as a C. Then this is the defining a new array here, and we are initializing that array as 0. Means you are just putting the initial value, base value as a 0, and here you need to consider it another loop for updating the value of count array. Before going for this all the steps of counting array, first we go for the working process of your counting array, then we will revert back to this algorithm, that how this algorithm gets worked. Here I am taking some examples. Suppose we have this array which contains different numbers, and obviously there are repeated number. So count this array. To sort this array, you are using a count array. Count array is just defining, I'm just saying that count array will have k plus 1 length. What is K here? K is defining the maximum element of your given array. Suppose we have array A and these are the elements, and in this you can see that the 9 is the largest number. So in count array, this should be the length of 9 plus 1, that is 10. You need to define the 10 length array. Here you are just using the values, suppose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just giving the indexing of each element. Yes, we are starting from 0, so you can say that n is equals to 17. 17 elements are total here. And when you're creating a count array, this should be the 10 element, or you can say from 0 to 9. Now you need to count the each and every key element, how many times it occurs. What is the meaning of this? You need to start a loop from this, from here, from 0 to n. And then if that number is, just access that number and update the value of count array according to that. It means to say that first initialize the count array as 0. Each element is having 0. First you are encountering the 2. So then go for the second position of your count array and update this value by 1. Update this value plus 1. Here you can draw 1. Again increase the counter. Again you are facing the value 2. Now again update this value, that is 1 plus 1, that is 2. Next your pointer will get moved again and you are encountering the value 9. Here you need to update the value of 9th position, that is by 1. Then update the counter and go for the next element. You are facing the element 3. Here you need to update the value of 3, counter value by 1. Again 3, update this value by 2, facing 1, and so on. We are just counting the each and every key, which is the basic concept of your counting sort. You need to count each and every key element. Again you are facing 1, update this value by 2. Again you are facing 1, update this value by 3. Now again facing 0, update this value by 1. 0, update this value by 2. 4, update this value by 1. 5, update this value by 1. Again this is 2. 7, position 7, update this value. 8, update this value. 8, update this value. And when you are facing 9, update this value by 2. Now just erase the value and get the updated count array. That is 2, 3, 2. That is 2 also. And that is 1. This is 2. And you have this 1 here. This is 2 here. And again you have 2. Now this value is just showing that you have 2 zeros, 3 ones, 2 twos, 2 threes, 1 4, 2 5, 0 6, and 1 7, and 2 8, and 2 9. This is just counting the each and every key element. By using this count array, you can sort the given array. How can you do this? Just now you need to update the count array. You need to count the array. You need to update the count array. How to update the count array? You need to say that count 0, value of count 0 will remain same, and you need to update count 1 is equals to count 1 plus count 0. You need to add previous value with this. I mean to say 0 will remain same, but in case of 1, this will become 2 plus 3, that is 5. Count of 2 will become 5 plus 2, that is 7. Count of 3 will become 7 plus 2, that is 9. Count of 4 will become 9 plus 1, that is 10. Count of 5 will become 10 plus 2, that is 12. Count of 6 will become 12 plus 0, that is 12. Count of 7 will become 12 plus 1, that is 30. Count of 8 will become 13 plus 2, that is 15. And count of 9 will become 15 plus 2, that is 17. Make sure that the last number of your count array should be equals to the n, number of elements in your given array. If you are getting any difference here, it means your counting is wrong. Something is missing in your question. So make sure that the last value of your count array should be equals to the given number of elements. Here, now I'm just updating this value again. This was 5, just to get a clear picture of this one. This was 7, and then 9, and then 10, 12, again with repeating it's 12, then 13, and 15, and 17. This 15 and 17. Now by using this count array, you can update the array B. Array B is another temporary array which is useful, which we are using for sorting the array A. How to perform this one? Now you increase, you now start another loop, but from last one. Means you need to start the loop by n minus 1 position and then pick the value of n minus 1 position. Here you can say that this is the 9th value. Go for the 9th position of your count array. Count array, you are getting the 17. Decrement the counter of this one by 1. That is, put it at 60. Now, put the value of A of I, this is your I, at the 60th position of your array B. Here I'm again counting this value, just giving the index of your array B so that we can easily count. This is 0 index, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Now you need to put this value, that is A of I, at the 60th position, that is 9 will get here. Now update the loop. Your I will become this one. Go for the 8th position of your count array. 8th is containing 15 value. Decrement it by 1, get it 14, and put this value at the 14th position. Now update again the loop. You are getting 8 value here. Again go for the 8th position of your count array. Now it's containing 14th value. Again decremented by 1, that is 13, and put the 8 at the 30th position. Now decrement counter again, that is go for this next one, that is 7. 7th position of count arrays containing 13 value. Decrement it by 1 and go for the array B at the 12th position and put the value 7. Now decrement the value this 5th position. Count array at the 5th position, you have 12th value. Decrement it by 1 and put the 5 at the 11th position. Now again update the loop, and again 5th number is there. Go for the 5th position of count array and check value is 11. Decrement it by 1, that is 10, and at that 10th position put the value 5. Now go for the 4th index, you have value 10. Update this value, decrement this value by 1 and put the 4th at the 9th position of your array B. Again decrement the counter, you are getting the 0. Go for the 0th index of your count array, value is 2. Decrement it by 1 and at the what position? First position you put the value 0. Again you are facing 0 here. Go for the 0th index of your count array and decrement the value by 1, that is 0, and at 0th position put the value 0. Go for the next one, 1. Go for the count index of 1 and here value is 5. decrement it by 1 and put the 1 at the fourth position. Now again you have 1, go for the 1th index of your count array, decrement it by 1 and put the 1 at the updated value. Again update the counter, go for the next one, and here again go for the 1th position of your count array and update the value by decrementing 1 value and put the value here. Now you are getting the 3 here. Go for the 3rd position of your count array, you are getting the 9th value, decremented by 8 and put the 3 here. Now go for the again next update the value. Again go for the 3rd index of your count array, update the value by 7 and put the 3 at the 7th position. Now next element is 9. Go for the 9th index, you are having the 16 value. Again update this value and put the 9 at 15th position. Now go for the next value, that is 2. 2 is containing value 7 here. 7 get updated by 6 and then put the value 2 here. Next value is again 2 and update the value of 2nd position by decrementing 1 value, that is 5, and put the 2 here. Now loop gets terminated and you can see that the value of array B is sorted element. Now we will go for the complexity analysis, or you can say we will revert back for the previous value. We will return back and we will check whether this value is we will check for the complexity of this algorithm by accessing this algorithm here. Here you can see that we are defining again this count array, and the length of this count array will be what? K plus 1. And here we are starting a loop I from 0 to K. This loop will work for the n length. K times this will execute. Then again, we are updating the count array by getting the value. We are putting the values here, and this will also execute it from 1 to a dot length, that is you can say n times. Then again this loop in algorithm is also working for the k times, and again this loop works for the n element. If you are talking about that, how to solve this problem by coding algorithm, you can also do this. Here we have make some function here. We are just doing the same thing which you are performing in your working process. Here I am initializing a count array with the same length. You can say that k plus 1 length, and we are defining another array of n length. Here I'm creating this loop just to count the each and every key element and update the value of count array. This loop will get executed n times. Again, starting another loop from 1 to k times, and this loop will update the value of count array, means you will get the final value of n is equals to given the last value. It will execute k times. Here you can say that count of 1 is equals to count of 1 plus count of 0. Count of 2 is equals to count of 2 plus count of 1. We are updating the count array here, right? And after updating the count array, what we are doing, we are picking the value of last value of AI, and we'll go for that particular value as an index for the count array, and then decrement it by 1. And when the updated value gets, you will store at that position which value we will store, that is AI. This is what we are doing in the question part. Again, this loop will get executed n times. And again, we are executing this loop by accessing the each and every value each and every value of B to A. So here you can calculate the time complexity of your algorithm. That is, you can say n plus k plus n plus n, or you can say 3n plus k. And when you're talking about complexity in terms of asymptotic notation, you can say that the complexity of an particular algorithm is O of n plus k or O of n, where k is the constant value because it will be very small value. This is the basic prerequisite of counting sort, that is saying that the k value should be small. And that is also a drawback of, you can say, that counting sort, that k will always be in terms of n. It can be n, it can be 2n, it can be 3n, but it can never be n squared. This is a prerequisite, or you can say assumption, some assumption about the input in your counting sort. Second drawback of your counting sort is that you cannot perform counting sort in decimal value and negative value. And third is that you cannot perform a counting sort in which number of gaps, or you can say numbers interval, is very larger. Then you cannot perform this value. You cannot perform this sorting algorithm. This is all for the counting sort algorithm. Thank you very much.